Welcome to this tutorial on dividing and then multiplying rational expressions and rational functions. Now the problem we see on the board is a division problem. Rather than doing division, what we want to do is convert it into a multiplication problem. So we're going to look at this as one expression that I'm bracketing on the left and another expression that I'm bracketing on the right. And what we're going to do first and foremost is we're going to change it from dividing those two things to multiplying those two things. In order to do that, we are just simply going to rewrite the first expression. The numerator is x cubed minus 9x over 4x squared plus 7x minus 2. And our denominator there is x squared minus 2x all over 25x squared minus 1. That stays the same. Now in order to change this problem from a division into a multiply, we have to take the reciprocal of the item in the other set of parentheses. By that, what is on the top of that big fraction has to go on the bottom of the big fraction. And what is on the bottom of the big fraction has to go on the top of the big fraction in order for us to have changed it from a division to a multiply. So up here in green will be the 4x squared minus 9x plus 2 all over 5x squared plus 14x minus 3. In magenta, this is 5x squared plus 11x plus 2 all over the x squared plus x. Now that it's a multiplication problem, we are then going to get rid of these other division symbols that we have in the problem. So, namely, we need to get rid of this division symbol right here and this division symbol right here. Now to do that, and we will color code completely, on this expression over here on the left, what we need to do is leave the orange alone because it's the numerator. And when we're dividing fractions, we leave the numerator alone. So that'll be x cubed minus 9x all over 4x squared plus 7x minus 2. 4x squared plus 7x minus 2. Then we're going to multiply, but we're multiplying by the reciprocal of the stuff in blue. So that'll be 25x squared minus 1 all over x squared minus 2x. Now the reason we're doing that again, and listen carefully if you're a little bit unsure on this, in order to get rid of dividing by the blue fraction, we multiply by its reciprocal. Next up, we continue this multiplication problem. And now we've got another expression. Well, when we divide by a big fraction, we leave the numerator alone. So the part in green will remain unchanged. 4x squared minus 9x plus 2 all over 5x squared plus 14x minus 3. That remains unchanged. However, instead of dividing by the magenta fraction, we are going to change it into multiplying by its reciprocal. So when we multiply by its reciprocal, it'll be x squared plus x all over 5x squared plus 11x plus 2. Now some people try to do all of this in one step. I think that gets a little bit confusing. So I would advise you to break it down as we just did. And now it's just a multiplication problem. So to recap multiplication, we just factor each of the numerators and factor each of the denominators. Here, we pull out the greatest common factor of x, which leaves us with an x squared minus 9. Oh, in blue, two numbers that multiply to be 25, x squared would be 5x and a 5x. And then if in one of those we put a plus 1 and a minus 1, that'll work. Over here, what if we went, I think that's going to be 4x, and then if we put a minus 2 here, that turns into a negative 8. We would have a negative 9. That works. Watch for the greatest common factor over here in magenta. We're going to divide all of that. Now let's see here. This is going to be, I think, a 4x, x, Need a minus 2. We can put a plus 2 here. That gets us the 8x. Minus 1 here gets us 7x in the middle. We have the minus 2. Watch for the greatest common factor. Pull out the x. Here in the green, we're going to get a 5x and an x. Needs to have a 3. If we put the 3 here, we get 15. We want it to be a positive to get a plus 14, and then we have to subtract 1 over on this side. And last but not least, we'll have the 5x and the x here in magenta. If we put a 2 and a 1 and add both of them, that'll have the plus 2 on the end, and 10 plus 1 would be our 11. Now hopefully you're good on the factoring. We've done quite a bit of factoring in this class. One other thing, we have to change this x squared minus 9. How do you factor x squared minus 9? And rather than rewriting all of that, I'm just going to back up here and put that this was x times x squared minus 9. That's going to turn into an x times an x plus 3 times an x minus 3. So now what we have to do is look for things that cancel or combine. Let's look carefully. Well, we've got these x's right here cancel. We've got x plus 3's that cancel. We've got a 4x minus 1 that cancels. Looks like we've got a 5x plus 1 that cancels. Notice how I'm using different markings to cancel things. It helps me stay organized. 5x minus 1 is canceling. Oh, we've got this, let's see here, x minus 2 cancels. We can cancel the x minus 2. Watch out over here, I'm seeing something. This x plus 2 combines with this x plus 2. Looks like that takes care of the denominator. Up in the numerator, nothing cancels with the x plus 1, the x, or the x minus 3. So I think that's all we can combine. Now what's left? Well, up in the top we've got our x, we've got an x minus 3 over here, and then we've got the x plus 1 over on the far side. In the denominator, it looks like we have an x plus 2, the quantity squared that remains, and everything else is accounted for. So this should be our final answer that's highlighted. But now to recap, with division, first convert it to multiplying by the reciprocal. And then sometimes you're going to have another scenario where you still have to convert a division into multiplying by the reciprocal, where you have to convert a division into multiplying by the reciprocal. Then, once we're multiplying, we just factor everything and look for factors that cancel or combine to simplify accordingly.